Okay, in this video, we are going to talk about some basic trig ratios using right triangles, and then we are going to solve some problems. So let's see what we got here. So use the definitions of the three trig ratios to complete each statement. So remember, some old hippie came around here to offer apples, or some old hag came around here to offer apples. So katoa, that's the mnemonic way we have of remembering. Sine is opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. So on these, we're using angle A as our reference angle. So in relation to angle A, the hypotenuse is always opposite the right angle, and then the other side of the triangle that makes up the angle besides the hypotenuse is the adjacent side, and the side that we look across the triangle at is the opposite side. So we have to kind of think about what we have in relation to our reference angle in terms of opposite and adjacent and the hypotenuse. The sine of A is opposite over hypotenuse, so the opposite side is M. The hypotenuse is P, so M over P is the ratio they're looking for that one. For cosine, adjacent over hypotenuse, N over P. And tangent is opposite over adjacent, M over N. Okay, in number 2, we're using this angle C as our reference angle. So again, the hypotenuse is always opposite the right angle, or it's the longest side. Opposite the C is X, and adjacent to the C is side W. So sometimes it helps to have these labeled just when you're doing a bunch of these to kind of keep things straight. So sine of C is opposite over hypotenuse, opposite X, hypotenuse Y, X over Y. Cosine of C, adjacent over hypotenuse, W over Y. And tangent, opposite over adjacent, X over W. Okay, let's look at number 3. Now, for number 3, they switch it up on us a little bit. They're giving us numbers, and we don't really know what the length of the hypotenuse is, so this is where we can use Pythagorean theorem. This is, I think, a Pythagorean triple, but let's check and see. So 8 squared is 64, 15 squared is 225, and those add up to 289, and the square root of 289 is 17. So this is a Pythagorean triple, 8, 15, 17, which is a good one to know. It doesn't occur a whole lot. On standardized tests, you'll see a lot of 5, 11, 12s. 5, 11, 12. 5, 12, 13s is one that occurs a lot on SAT type tests because it's not so obvious as a 3, 4, 5. So, but it can give you a shortcut. So if I'd recognized that this was an 8 and a 15 Pythagorean triple, I would have known right away that that was a 17 and not had to go through the Pythagorean theorem. But now we know what these side lengths are. Let's do this. So we're using B as our reference angle for this first column. In relation to B, 15 is an opposite, 17 is hypotenuse, and 8 is adjacent. So sine is opposite over hypotenuse. We've got 15 over 17. Cosine B, adjacent over hypotenuse, adjacent 8, 17 hypotenuse. And tangent is opposite over adjacent. Opposite B is 15, adjacent is 8. We got 15 over 8. Now, next column, we're doing A as our reference angle. So now A is our reference angle. So what happens with that is the opposite and adjacents change. The hypotenuse is always going to be opposite the right angle, so that stays the same. But now the opposite side to A is 8, and the adjacent side to A is the 15. So sine of A is opposite over hypotenuse, that's going to be 8 over 17. Cosine A is going to be adjacent over hypotenuse, that's going to be 15 over 17. And tangent of A is going to be opposite over adjacent, that's going to be 8 over 15. Now, we actually wanted to find out what one of these angles was. We could use any of these ratios here with our numbers, turn this into a decimal, and then we could do inverse cosine, cosine minus 1 of whatever that decimal is, and that would give us the measure of angle B. And then we could use complements. 90 plus B plus A measures have to add up to 180, and we could figure out what all the triangle dimensions were, and that would be what we would do to completely solve the triangle. But right now, we're just worried about doing the ratios. Okay, let's look at number 4. We got an angle F in the first column as our reference angle. So here's our angle F, and 9 is opposite, and 5 is hypotenuse. But this is a, let's look, this is a 3 times 3 to make the 9. This is a 3 times 5. Basically, we have a 3, 4, 5 Pythagorean triple pattern. 3 times 4 is going to be 12. So without doing the Pythagorean theorem, we can figure out this is 12. Otherwise, we'd have to do 15 squared minus 9 squared. 225 take away 81 is going to give us 144. And that's going to be our medium-sized side then, or our longer side. So we're doing sine of F. F is our reference. 9 is opposite. 15 is hypotenuse. 12 is adjacent. So with F as our reference angle, sine is 9 over 15, which simplifies, take it 3 out to 3 over 5. Cosine is adjacent over hypotenuse, 12 over 15. Take a 3 out of each, that's going to simplify to 4 over 5. And tangent is opposite over adjacent, that's going to be 9 over 12. Take a 3 out of both, that's going to be 3 over 4 for those. This column deals with sine of G. Now G is our other angle in the triangle. So opposites and adjacents switch their labels. So now the opposite to G is 12. The adjacent to G is the 9, and the hypotenuse is still the same. So sine of G, opposite over hypotenuse, 12 over 15, which simplifies to 4 over 5. Cosine of G, adjacent over hypotenuse, 9 over 15, which simplifies to 3 over 4. And tangent of G, opposite over adjacent is tangent. Opposite is 12, adjacent is 9. We got 12 over 9, which simplifies to 4 over 3. Take a 3 out of both of those. Okay, let's look down here. Oh, here we have a 1524. Let's see what's up with that. 3 times 5 makes 15. 3 times 8 makes 24. This isn't going to be a Pythagorean triple, I don't think. I don't think this is going to be a Pythagorean triple. So do Pythagorean theorem on this. 24 squared, which is, I think, 476. Take away 15 squared, which is 225. Leaves us with 251. Double check that. That gives us 476. Yeah. So we get 251. So the square root of 251 is the YZ length. Let me grab a calculator and see if that comes out to be a good number. 251. Square root of that. 251 second square root. Comes out to be like 15.8. So we'll just leave it square root 251. So we're going to leave it square root 251. Just let me, okay, 24 squared. Okay, 24 squared is 576. So we get 351 when we take that away. Let me check the square root of 351. It comes to be 8, so it's 351. That's 18.7. So it really doesn't, it's not any kind of a special triple or anything like that. So these are the ratios that we have here. If we're using x as our reference angle, sine is opposite over hypotenuse. Opposite the x is root 351. And the hypotenuse is 15. So root 351 over 15. Cosine is adjacent, which is 24, over hypotenuse, which is 15. And tangent is opposite over adjacent. That's going to give us root 351 over 24. Okay, let's look at z. Now, if z is our reference angle, 24 is opposite. 351 is root 351 is adjacent, and our hypotenuse is always opposite the right angle. And so if we're going to do sine, we're doing opposite over hypotenuse. With z as our reference, we've got 24 over root 351. Now we got 24 over 15. For cosine, adjacent over hypotenuse, root 351 over 15. And tangent is opposite over adjacent. We have 24 over root 351. Have to rationalize that. We get 24 root 351 over 351. Now this simplifies. If we need to simplify this, check for divisibility by 3. If the digits add up to something divisible by 3, then 3 divides the number. So we can take a 3 out of 351 since these digits add up to 9. 9 also divides the number, but 9 doesn't divide 24. So 9 divides into each of these, or 3 divides into each of these. It's going to give us an 8, and this is going to give us a 117. So we have 8 over 117 when we take a 3 out of the numerator and denominator. And that's as simple as we can get it. 8 root 351 over 117 is the tangent of z. Okay, over here, they're throwing an isosceles right triangle at us. So we should right away know that this is a 45, 45, 90, which gives us special ratios we can use. In a 45, 45, 90 triangle, we have 1, 1 radical 2 as our ratios for the side lengths. So let's see what we got. Sine of b is, they don't give us any numbers here, so we'll just let this be 1. The other side is going to be 1. This is going to be radical 2. Sine of b is opposite over hypotenuse, 1 over radical 2. Rationalize that, we get root 2 over 2. Now cosine, same exact angle, we're just coming from the other side. We've still got 1 over root 2, so we get root 2 over 2. Tangent is opposite over adjacent. We're using b, opposite over adjacent. We get 1 over 1, which is 1. We're going to a over here now. A is our reference angle. The sine of a is going to be exactly the same as the cosine of b. Sine of a is going to be opposite over hypotenuse, 1 over root 2, which is root 2 over 2 when we simplify it. Cosine of A is adjacent over hypotenuse, 1 over root 2, which is root 2 over 2. And tangent of A is going to be opposite over adjacent, which is 1. So that's how we would do those. 15 minutes. So let's look at these problems here. Using trig ratios in your graphing calculator. Okay, we'll save this for another video. Actually solving these problems. So the next video we're going to do is this other worksheet, which deals with a little bit harder problems for us to do.